Welcome everyone to lesson number 1 part 3 of this deep learning course series. My name is Fastai You, and in this lecture we are going to discuss about history of deep learning, what was happening in the pre-deep learning era. We will discuss about the applications which was developed in pre-deep learning era, and after arrival of deep learning what was happening. And we will learn about deep learning framework, and we will learn about Jupyter Notebook, which is actually used to create deep learning applications. The highlights of this course is we are remaking Fastai You course Practical Deep Learning 2022, and the original link is over here of this course. This one is the lesson number 1 smaller version, and this one is the part 3 of the lesson. I would suggest everyone to go to link number 13 and 14, and the notes are provided in a drive link. So the drive link is the link number 1. So I would suggest everyone to go there. So these are the outlines of what we are going to discuss in this lecture, and these are the resources. So this is the link number 1, and these are link number 13 and 14 for our notebooks. So let me go to my notes which I have developed for you, and as you can see, this one is the lesson number 1 part 3, and we are first going to discuss about pre-deep learning era. So we will discuss about how classification system was developed so quick now and why not before. So in this application we will discuss about image classification system, and this research was happened on Stanford University by a computational pathologist. Here you can see histopathology images. For example, these are histopathology images, as you can see here, and so it was like kind of classical machine learning approach by Daphne Koller, who was the author of this research. And she said that at that time deep learning was not popular, so she didn't use deep learning techniques. Instead she used a classical approach of machine learning techniques. And what was the idea at that time? So the idea was, so there was a team of mathematicians, computer scientists, and pathologists who created features and built the relationship between the pixels of the images. So here you can see, if we zoom here, you can see, so there are like kind of relationships which was developed, and a lot of features was developed at that time in order to predict a patient's survival. So in the result, they extracted the thousands of the features from these images, and feature extractions required a lot of expertise from cross-disciplinary team. And in the end we are discussing about the project resources. It required a lot of years, a lot of people were required to create these features, and there was like kind of lot of coding, and a lot of mathematics was required to develop those features in order to predict a patient's survival, a prediction system, in order to create a prediction system. So actually what happened, one, they created a lot of features. Through this, they fed those features to a model which was at that time was logistic regression model, and they predicted a patient survival. Here you can see, so the chances of the survival of the patient. So this was like kind of research, and this cannot be developed in the beginning of the course. So for example, if we want to create this application, we cannot do that in 3 minutes. So deep learning model build us, we are creating the applications like in the deep learning model. These features will be created automatically by those models. So general view of, so first of all, in deep learning we will learn about what neural networks are. So general view of, I will give you a general view of neural networks. In 2015, Matt and Rob done this kind of research about neural network, which is kind of model, as I said, in deep learning. They trained a neural network, and the idea was, actually, as I said before, you don't have to create those features. We will ask this neural network to create those features for us. So neural network will learn those features. I will show you how it learned. And they created a pictures, how they, in the form of picture, they represented how they learned those features, after creation of those features by neural network. They show it in the form of the images. So for example, so we were having these set of images which are 9, like in this case 1 2 3 4 5 6 7 8 9, and these were this automatic set of weights, you can call it weights or features, which was developed by a deep learning neural network. So these was the images which are kind of images which are used to detect those kind of images in the layer 1. So I will go through that, what is happening over here. So let's talk about what are the set of weights and what they do with the images, what are the relationship with those images. For example, if we talk about box number 1, so we have the images like diagonals and like kind of diagonals, and this particular box number 1 here is used to detect those kind of images. As you can see, there is a curve over here. And if we talk about last box, which is red to green, and if we talk about the box number 6, so this is the box number 6. If we talk about this one is used to find the yellow to blue gradients. What are gradients? Gradients are the rate of the change. So box number 6 is used to detect this kind of images, like how to detect yellow to blue change in the images. So it's used to filter those kind of images. And the last box was used to filter red to green kind of images. As you can see, it's red over here and the green is over here. So these are the combinations and the filters of those kind of images. And why we are talking about why deep learning is deep. Actually, we can learn more complex features through deep learning techniques. I will show you. So we can take those features combined to create more complex features. So this one, the previous layer was layer number 1, is used to detect red to green change, red to yellow change, diagonal images, kind of images detector filter like this. But if we go more deep, like for example in layer number 2, and if we talk about the box number 12, so the last box is used to detect like these kind of images, like which are like a bit curvy or bit like kind of which is used to detect lines. And if we talk about box number 7 over here, this one is used to detect the curves. So for example, the curves like this, for example moon detector or sun detector or something like this. If we talk about box number 6, it used to find circles. So we can find circles, we can find curves, we can find the diagonal, horizontal or vertical lines through the different filters. And these filters will be automatically created for us through deep learning. So we don't really have to write a code for it. We will just feed these pictures, we will give examples to the neural network, and these features will be created on its own by a neural network. And also you must have to provide a kind of pictures like these kind of pictures in order to have those features from a neural network. We can even create more complex features. For example, if we talk about layer number 3 in neural network, the box number 1 is detecting the geometric shapes, as you can see over here. So geometric shapes like this. So these are like kind of more complex features, and these are the filters of those kind of images. And if we talk about the last box, so it is used to finding the edges of the flowers. So this kind of, if we see this box, these kind of boxes, it is used to detect the images like this, the curves in a flower. And if we talk about box number 8, so where is the box number 8? So box number 8 is here, this one, and it is used to detect the numbers, or like the numbers like this. It seems it is used to predict the images like this, which contains number, or like this kind of box. So the second last box is used to detect if there is a human or not. So we can learn more complex features through deep learning techniques. So deep learning can find more sophisticated features for you. So deep learning can find more sophisticated features for you. We will learn how neural network can do it for us automatically. So I will repeat again. So no coding is required for creating those kind of features. So these are layer number 4 and 5. I will suggest everyone to see those pictures and the filters, the features which are created for these kind of pictures by deep learning. So the next thing is, image-based algorithms are not just for images. You can convert, like for example, sounds recording to images. You can convert a time series like this in the form of images, and you can convert mouse clicks in the form of images. I will discuss this in a brief. You can convert sounds to the images. You can convert different kind of domain data to images, and you can build image classification system. So for example, in this case, you have to learn different some foundational techniques for that, and you need to be a kind of creative for that. For example, there was one student who converted a sound data to images in form of like this, and it so this data after the conversion of this data was fed to image classification system to classify a specific kind of genre, for example in this case, or specific kind of, you can find the specific kind of sound classify. You can classify that like bird and no bird kind of classification system. And in this case, there were like kind of a time series data which is here, and one of the student converted this data. The name of the student is over here and he converted data to this kind of pictures and fed those pictures to image classification system. And if we talk about mouse, so there were like kind of clicks which represented in the form of dots, and the movements represented lines. So, and the color in the lines shows the speed of movement, and the colors in the clicks shows the speed of click, the intensity of click. So a lot of people might have said you that there are like a lot of prerequisite of deep learning course, but it is not required in general cases. So you might be heard about it required a lot of maths, lot of data, and a lot of expensive computers are required to create deep learning applications. But the truth is, you will require some high school mathematics and 50, for example, in order to build image classification system, less than 50 images are fine for you in order to develop those the classification system. And if you want to develop the application, less than 50 items of the data are sufficient for that. And you might be heard about there were like some companies who want to sell their machines to store for you to store a data. So like their intention is to sell the machines for you to store a data. So it doesn't require a lot of data to create deep learning applications in the real world, at least. So how that happened? It was happened because of transfer learning, which is like kind of a domain of deep learning. And with the transfer learning, you can create state-of-art work now. We will learn about how in this course how you can do a transfer learning. And the next thing is, which is really interesting, we are discussing about Pytorch. The Pytorch will be used as a framework. We are discussing about framework. So in order to develop the application, you will require a set of rules you need to follow to create those applications. So framework is something like this. So framework provides you a set of rules in order to create those kind of applications. So there were like commonly two frameworks in the domain of deep learning, which was TensorFlow, which is dying right now, and the Pytorch is growing right now. And this course is based upon Pytorch. So TensorFlow in the tiny majority in a research repository, as you can see over here in this graph. So this yellow is showing about the use of TensorFlow framework, and reddish kind of color is showing the popularity of Pytorch, and there are like some other kind of frameworks as well. So why we mention those? Because if you learn why we are mentioning that that graph, because if you will learn the Pytorch, so if you learn Pytorch instead of TensorFlow, so when you go in the real world, so a lot of industries will work on the same framework what you have learned in this course, because it drives industries as well. So research always drives industries. The next thing, what this course uses, so as I said before, we are using Pytorch, and there is a blog over here, TensorFlow versus Pytorch. You can search in a Google, and it will help you to understand why we are using Pytorch in this course. And another thing is, so there was a kind of research which happened on 2018. So another thing is, there was a research which was happened on 2018 about Pytorch, and so in this research, so they found out that lots of people using TensorFlow are shifted to Pytorch. As you can see over here, if I will zoom it, like, so there are like 50% of the people who were in the Pytorch shifted to TensorFlow in 2019, and there were like around 55% of the people who were using TensorFlow as a framework were shifted to Pytorch in 2019. So this is another reason for using Pytorch. So in this cell I will show you about a kind of optimizer. So you don't first of all, you don't need to understand what optimizer is. So this is just an example, a kind of code of Pytorch. So this code is shown here in this picture, and it was copied from Pytorch repository, and it requires a lot of heavy code to do simple stuff. Particularly if you see the Atom optimizer, if you want to create an optimizer like this, so you have to write this code in order to, which are like having a lot of lines if you have to create an optimizer like this in a Pytorch. So this is just an example. Don't worry about if you don't understand about what Atom optimizer is. So so this is just to show you why we are using Fastai framework. So actually with the Fastai you can implement the same thing in a simple way. So what is happening right now? So code was shown to you about Pytorch, and I will show you how the same code is converted in a simple way by Fastai. So I will show in the picture later on. So Fastai was built on the top of Pytorch actually. So the bottom thing is Pytorch, the bottom code is Pytorch, and Fastai is utilizing this code in order to create a simple code. So this is just if you are novice in the deep learning, so this is just a simple way I can say. It is not because Pytorch is bad, because Pytorch is designed in such a way to build things on the top of it, like Fast.ai library. When you will install Fast.ai, you will have all the power of the Pytorch. Why we are doing this? As I said before, because it requires a lot of code to writing in a Pytorch. It requires a lot of code writing if you write purely in Pytorch. So you will have more chances to make a mistake because you have to write a lot of code, and so a lot of practice is required, and you have to maintain this code as well. So less code is better for deep learning. So this is the image of the same Atom optimizer, and this gray shaded thing over here is used to call the optimizer. So you can see it. So this is very simple way. This is very simple thing. With Fastai we have created the same line of codes in the simple way, and provided code with Fastai you will get better result actually. And with Fastai has been widely used in industry, academia and teaching as well. As we will go deeper and deeper, we will see more and more pure Pytorch, because the top is Fast.ai and the bottom is, because if we will more analyze deep learning things, we will go to the Pytorch. We will see the pure Pytorch power over here. And Fast.ai was given the best paper award in 2020. So this was the title, Fastai, a layered API is application program interface for deep learning. For deep learning, this is the best library, and this award was given. Kudos to Jeremy and Sylvian. So the last thing we are gonna discuss over here is about Jupyter Notebooks. So Jupyter Notebooks are the kind of environment which is used to do a computational work related to deep learning in order to develop applications in deep learning. So this is kind of web-based application which is extremely popular and widely used, and you can explore, experiment and building applications through Jupyter Notebook environment. So there is, in this picture you can see the example of Jupyter Notebook. So you will write, there are like kind of cells over here. You can write Python code to create the application. You can run Jupyter Notebook on a cloud server instead, and local machines as well, in your local computer as well. So if you are interested running Jupyter Notebook in a cloud server, so you have to watch lesson number 0 in this course series. And the next thing is, you can go to course.fast.ai, and there is kind of tab over here which you can in which you can see the different ways, the different kind of platforms which are provided to you in order to develop Jupyter Notebook, in order to develop the application through Jupyter Notebook. So these are, most of them are free actually. So Kaggle not only contain computations, it also contain Jupyter Notebook server, cloud server. If you are interested, you can click on this link in order to see the notebooks developed by the original author of this course. So go here, and you will see the list of notebooks like this, and you can click on Jupyter Notebook 101. So when you will click Jupyter Notebook 101, when you will choose this, you will see Jupyter Notebook 101 title over here, and you will see the whole notebook. So there is one example in front of you, Jupyter Notebook 101 title, and you will find the two buttons which are edit, and there is upvote, which is used. If you upvote it, it will help others to find this particular Jupyter Notebook 101 quickly. And the next thing is, we are going to discuss about how you can use this Jupyter Notebook. What are the basic features of this Jupyter Notebook? You can write, first of all, you can write any Python expression after clicking edit. After click on edit and copy, you can write any expression. And in our case, we have written 1 plus 1 in a code cell, and the session will be started. So when you run it, like click on play here, the session will be started for you. So why we are having a session? The session means there would be a kind of virtual computer which is launched for you in a cloud server, and after the session will be start, and you can actually write Python code in the different cells. Python and JavaScript are two top languages. So Python knows how to make calculations, so you can even write 1 multiplied by 1, 1 multiplied by 3, or 1 divided by 3, if you know basics about Python. If you don't know basics, you can search in a YouTube, and you can learn some basic operations in Python as well. So if you don't want to click on play sign, you can go to the cell, and you can press shift plus enter to run the particular cell. The next thing about Jupyter Notebooks are code plus markdown. So there are like two kind of cells. One is code and one is markdown. To summarize, a code cell lets you to do a calculation or write a code in Python, and in markdown cell you can write a documentation, like something like whatever you like in Microsoft Word, or so it has some particular rules to write it. You can learn about what are the rules to write it. If you know about latex, if you know about a bit about kind of Microsoft Word, you can add links, or you can search in a YouTube what are the rules about markdown cells. So you can learn about how to create a documentation along the coding cell as well. So I would suggest everyone to search in a YouTube about the tutorials related to Jupyter Notebook, or you can see this particular Jupyter Notebook in order to learn more about about this. We will gonna see it. So another thing, the last thing, in a Jupyter Notebook, sometimes you might found there is a exclamation mark over here. So why we are having this? This is used to represent about a bash command, which is not a Python, which is kind of bash command to interact with the machine, with the operating system, which is used to run this Jupyter Notebook. So for example, if I want to see a current directory which is attached to this Jupyter Notebook, so there is a path of that directory, Kaggle, and that working directory. You don't need to learn about it right now, but like you can see, when you further go to the different lessons, you will understand what is a bash command and what is the difference between bash and Python command. So Jupyter Notebook in 2017 won the ACM Software System Award, which is the best award in that particular field. So now I will gonna show you a little tutorial about how to use Jupyter Notebook. So I will go here, I will open my Google Chrome, and so there is Kaggle and Howard and notebooks over here. You can search here. So we are in the we are having here the list of the notebooks created by the original author of this course, Jeremy Howard, and you can search about the particular Jupyter Notebook. In our case, it was Jupyter Notebook 101. So I will click over here, and there are kind of two cells. So this is cell number 1. If I will double click over here, so first of all, what you will need to do, you will need to give a vote, which is 7:45 now, and you can click here in order to make your addition in this Jupyter Notebook. So I will not explain in detail, I will just show you how you can use Jupyter Notebook. So after you clicked add it, you come here, and here this one is the heading. So heading is, this is a markdown cell actually, and this one is the heading. So if you want to create a heading, you have to put double hash before the text, and it will result in this, with this kind of text. And there are, if you double click over here, so this is another markdown cell, which is like kind of used to create a documentation. And if you are interested in writing a code or calculations, so this is a code cell actually, and if you press shift plus enter, it will run it, and there is the output over here, which is 2. If you want to add another cell, which is kind of, in my case, I will add a code cell, I will click here, and I can write 1 multiplied by 2, and I will press shift plus enter, or I can press here to run it. So I will press shift plus enter. And if you want to create markdown cell, so markdown cell is something like this, is used to create rows. If I want to bold it rows, what I will do is star over here and star over here to make it bold, and shift plus enter will result this one. I would recommend everyone to read this. What are the rules to write in a markdown? And so if I double click over here, you can add links as well. So this is a link, and for example, if I will press here, I will go to this particular link. So this is a basic thing about Jupyter Notebook, which contains 2 cells, markdown and code cells. And thank you so much for your patience, and thank you so much for watching these videos, and if you have any problems, you can write in a comment section of YouTube video. Another thing is, I would suggest everyone to go to Forums.fast.ai if you have any kind of ambiguities, any kind of confusions. You can create a topic over here, and there is a community which will answer you about everything, every confusion related to this course. You can subscribe to this channel to encourage me, or you can like, if you are interested, you can like the video, and you can comment in a video as well. And thank you so much. In the next week I will come up with a part 4, hopefully, and goodbye for now. Have a nice day.